Hello guys, today we have a very essential and necessary video because today we are going to see about a very essential, necessary and very essential study to understand physics. Physics is a very complex, has a very complex theories like quantum mechanics, but to understand them we have to understand this interesting part first. Today we are going to see about that. I think you have guessed that we are going to see today about the introduction part in physics. Today we are going to see about a few things like what is science, how we can classify science, what are the studies contained under science, and what is physics, what is physical quantities, and what are physical quantities, how we can classify physical quantities, and what are non-physical quantities, what is the difference between physical quantities and non-physical quantities, and vectors. What is the father of vector first, and how we can classification of vector and addition and subtraction of vectors is contained in the next video. And today we are going to see about only the introduction part of vectors, like what is vectors and how we can represent vectors. So I said, be with us, you will get a greatest of knowledge. And first we are going to see about what is science. When we talk about science is a very interesting and a very essential part. I think science is a very wide, due to science is a study of a study of something is classification. When we come to classification of science, due to because science is only a study of anything, a study of anything in the universe, a study of anything, even if there is a universe other than without this universe. If there is other universes, physics also studies about science also studies about them. Science is a study of anything in the universe and also in our earth. And when we came to the classification of science first classified into two: natural science and social science. When we talk about social science is a study of the society, a study of relationship, a study of structure, a study of arrangement of the society. It is only deals about the earth. That means are the peoples and humans live only on the earth, because social science is a study of the society. Society is emerged on earth. I'm not talking about aliens. We don't know about aliens. We are not sure about aliens. Due to that, civics, social science studies about only the earth. But when we came to natural science is a study of all the universe. And first, the definition of natural science is: natural science deals about the nature and anything included in the nature. Natural science is a study of anything in the universe. We can say that as a science. We can include it in science without the relationship and other things in the society. He deals all about the universe without the society. So it can be dealt sometimes about the society. For example, physics is a study of measurement. Due to that, physics can be measure the density of the people living on the earth. So it have deals about the society. But without, sometimes physics is a study of without the society. So no physics, sorry, natural science is a study of other than the society. And we can subdivide social science to many groups. Let's see two of them: civics and geography. By the way, geography is not only the study of social science. Geography, we can assume geography like a bridge of natural science to social science. But I don't know why scientists include geography in social science. And natural science also can subdivide it into many groups, like the first one is the essentials are physics, chemistry, and biology. Let's see them one by one. Physics is let's see chemistry first. Chemistry is a study of matter, non-living things. Matters are non-living things, so a study of non-living things. And biology is a study of living things. So the relationship between biology and chemistry is the relationship between biology and chemistry, or any parts of the natural science, have a relationship between each other. So a study deals both about the living things and non-living things is known as the study of the combination of biology and chemistry. So when we combine biology and chemistry, they deals about both the living things and non-living things. And the other is biology is a study of life and living things, which is living on Earth. There is other planets which have living things, but now we are talking about the biology. It studies about all living things. Well, so in social science, when we talk about social science is study only about humans. But biology also deals about humans, but including all living things on Earth. The other is we are coming now up to the definition of physics. When we talk about the definition of physics, many definitions have been given to physics, depending on their branch, depending on their study of physics. The study of physics can be classified into much groups. Due to that, only the studier or the giver of that explanation about physics give the explanation depending on his study branch. That means, for example, if I am a mechanics physicist, so I give a definition for physics depending on my branch or my mechanics branch. If I am an optics scientist, I give a definition for physics depending on optics or light. This is why the definition of physics is not one or two. So the other is there have many definitions have been given to physics. A very great definition and which express physics essentially are: the first one is physics is a study of measurement. That's correct. Physics is a study of measurement. Without measurement, no physics. Without physics, no measurement. So physics and measurement is a very related parts. And if there is measuring, there would be a physics. If there is no measuring, there didn't be. We can't find physics. So physics is depend on measurement. And the other definition is physics is a study of motion. Yes, physics is a study of motion, but including structure and behavior of matters. As if we say physics is a study of motion only, sometimes there is without motion, physics can study. For example, I am sitting here, but physics is here on me. We can measure my my weight from I'm sitting, but we can measure my weight. Weight is a physical quantity, so weight is concerned with physics. So physics can be founded when we are not in motion. Due to that, this definition includes that the structure and behavior of matters. Sometimes the main branches of physics are the first one is the motion branch, and the second one is non-motion branch. The non-motion branch, including the non-motion branch and a motion branch. Physics is a motion branch. Physics is a study which includes the motion branch and non-motion branch. So the other definition is physics is science contain all natural science parts. So without some parts of nature, physics contains many of the natural science parts. Like physics has a relationship with all natural science studies. Due to that, we can talk that physics is a study of anything without including some a very few parts. The other is today we are going to see about quantities. Quantities can be classified into two: physical quantities and non-physical quantities, defined quantities and non-defined quantities. That means the main difference between physical quantities and non-physical quantities are: physical quantities can be defined or measured, can be represented by a numerical value, physical quantities. But non-physical quantities can't be represented by numerical value. So the main difference between physical quantities and non-physical quantities is this. To see an example of physical quantities, we can see that we are measuring a width of some rectangle. It is a physical quantity. When we are measuring a length of some 2 points, that is a physical quantity. It has a numerical value. For example, if the difference between my fingers is 3 centimeters, we have represented in numerical value, so it is a physical quantity. And non-physical quantities are a study of not measured things like love, like fear. But physical quantities have their own study, like psychology and etc. A study that is concerned with physics is which study is concerned with physics from physical quantities and non-physical quantities? Stop the video and think for a minute. Yes, I guess that you get a physical quantity is concerned with physics, but non-physical quantities are not concerned with physics, because non-physical quantities can't be measured, but physical quantities can be measured. Measurement is a very essential to be a physics part. For example, fear is not measured, so it is not physical quantity, but force is measured, so it is physical quantity. Like love is not measured, it is not physical quantity, and it is not physics. It's not contained in physics. Like for example, energy is measured, it's a physical quantity, so it is contained under physics. We can classify physical quantities into two things. The first one is representation, and the second one is representation and their unit. Depending on their unit, we can classify physical quantities into two: basic physical quantities or fundamental physical quantities, and derived physical quantities. The difference between basic physical quantities and derived physical quantities are: basic physical quantities are physical quantities that directly measured. They are not derived, they have only one unit. That's not like unit in Newton, because Newton is equal to kilogram meter per second square, but it is concerned with, for example, use see meter. Meter is directly measured. We can't represent meter in terms of other units, so it is a basic physical quantities, a basic physical quantity. And derived physical quantities are physical quantities that are made by other physical quantities, or by adding physical quantities, by subtracting physical quantities, by multiplying physical quantities, or dividing physical quantities. But it is measured by other physical quantities. It depends on other physical quantities. It can't be measured directly. For example, let's see force. We can see force. Force, the SI unit of force is Newton. Newton is an SI unit of force. You can see that it is 1, but it is not 1. Newton is equal to kilogram meter per second square, because the formula of Newton force is mass times acceleration. Mass is kilogram, acceleration is meter per second square. So it is made, force is made by kilogram from mass, meter from length, second from time. So force is composed of three basic physical quantities: mass, time, and length. All non-physical physical quantities, derived physical quantities, are included, can be represented in terms of physical basic quantities, or fundamental quantities, physical quantities. There are only 7 fundamental physical quantities. There are many and many derived physical quantities. The basic physical quantities are 7 in number: length, time, mass, temperature, amount of substance, luminous instantaneous, and electric current. We don't have to see that they are vector and scalar, because we can understand from their vector and scalar definition. And let's see their units. For example, the unit of mass is kilogram. Kilogram is represented by kg. First, what we mean by unit and what we mean by measurement, by measuring. Measuring is when we represent something, when we compare two things by numerical value and unit. Unit means a reference standard used to measure. Measurement and unit are a very concerned, because measurement or measuring is comparing two things by using unit, and unit is when we access or when we measure, and unit is a reference standard used to measure. Have you seen? Even in their definition we can find each other in the other definition. We can find measurement in the unit, we can find unit in measurement. So they are a very concerned parts in physics. First, without unit, no physics, because we can't understand. For example, only numerical value can't give us a full definition about that thing. For example, I measure this road. It's 3. It's 3. What we understand from this? 3 meter, 3 centimeter, 3 kilometer, 3 terameter. What do you understand? Nothing. Why? Because we don't understand, we don't have unit here. But if I give you a unit, this road is 3 kilometers, you can understand easily. You can say that it's long or short. If I say 3 centimeters, it's very short, you can say that. If I say this home is 3 meters from Earth, you can understand that if it is short or long. But if I don't give a unit, you can't understand nothing. For example, I measure something, and it is 5 what? 5 years old? Is it 5 years old? No, it's not. We can't understand. We need unit to understand that thing. The unit can be 3 kilogram. I measure something, it's 3 kilogram. I measure his mass. We can understand that I measure his mass by using unit. I measure something, it is 3 kilometers. I measure its length. You can understand from kilometer or meter. So this is unit and measuring. The units of basic physical quantities are: the first one is mass, it is represented by kilogram. The second one is length, it is represented by meter. Time, represented by second. By the way, I'm talking about the standardized unit, not only the unit. One physical quantity can have many units, but I'm talking only about the standardized unit. The standardized unit of mass is kilogram. The standardized unit of length is meter. The standardized unit of time is second. The standardized unit of temperature is Kelvin. The standardized unit of amount of substance is mole. The standardized unit of electric current is ampere. The standardized unit of luminous intensity is candela. So they have a standardized unit for all of them. Standardized unit is an internationally selected unit or SI unit that used to represent the physical quantity. It is a main branch of their unit, the main unit from the other units. For example, the standardized unit of time is second, but it has many other units like hour and minute. But the internationally selected unit of this time, this basic physical quantity or time, is second. So you use second to represent it. Mainly you use second to represent it, but if it is long or short, you can change the unit, the standardized unit, to other units. And when we came to derived units have, we can give many other physical quantities for derived physical quantities. For example, energy, work, power, pressure, etc. are physical quantities that can be represented by in the terms of fundamental quantities or basic quantities. When we come to other classification of physical quantities, can be classified into two depending on their representation: vector and scalar. The main thing of unit 1 of student textbook of Ethiopia is about vectors. Due to that, we are going to see about vectors in the next video, but now I'm going to talk to you about the representation of vectors only. When we talk about the second way of classification of physical quantities, they can be classified into vector and scalar. Scalar is a physical quantity that only used to represent by magnitude only. Sometimes unit, it can be used unit. Scalar quantities represented by only magnitude and unit. So scalar quantities doesn't have a direction. We doesn't need any direction. But when we came to vectors quantity need a direction. It is essential to use direction in vectors quantity. Direction can be changed anything in vector physical quantities. For example, if we are going to north, 2 kilometers to north and 2 kilometers to south, the addition of the two vectors is not 4, is 0. We'll see it in the next video. But when we add vectors and physical quantities, we have to see their direction. Depending on their direction, we have to depend on their direction. That is not easy adding like scalars. Scalars are a physical quantity that represented by magnitude and unit only. So scalars can be added as I want, as a mathematics rule. For example, 2 plus 2 is 3. So 2 kilometers plus 2 kilometers is 3, because they doesn't have a direction. For example, let's see, I travel 2 kilometers to north. Then first 2 kilometers to north, then I turn to 2 kilometers to east. What is my total displacement and total distance? You know that, I think you know that displacement and distance are displacement is a vector quantity and distance is a scalar quantity. They are different. So when I travel 2 kilometers to north and 2 kilometers to east, my total distance is 4 kilometers. But my total displacement is not 4 kilometers. It is, I think, it's under radical 8 kilometers. Yes, it's under radical 8 kilometers. My total displacement is, but my total distance is 8 kilometers. And the radical 8 and 8 is a very different number. And the radical 8 is, I think, 2.8, like that. Okay, so there is a main difference between vector quantity and scalar quantity. That's all for today. Thank you for attention, and don't forget to like, subscribe, and share our video to get see a new videos to get a knowledge. So, but don't forget to subscribe, like, and share our video. Thank you for attention.